Hi everyone, welcome back to the series. Today we're gonna kicking things off by looking at ListQueues. Alright, this is very quite intuitive. Basically this is just a fundamental data structure when it comes to real world context and real world scenarios, okay? So it is a strict first in, first out data structure. So you are in a queue and the first person at the line who gets served first. So this is just a very common thing, right? So when it comes to real world, you're standing at the queue and the first person in the front of queue who gets served first, and the new people are connecting from the back, which is we call as tail or back, and the front is basically mean just head. Okay, so head and tail, there are two parts of the queue, head and tail. So the new people or new index and new node coming from the back, they're connecting from the back because the queue, that's the core principle of the queue, and the first cells or first removed nodes are beginning from the front or head. So this is the core principle, this is the whole principle, you know it, you just know it from a common sense, okay? So it's just very simple. A lot of beginners try to make these from arrays, but the problem is memory management. When it comes to real scenario, when you remove an index or node from your computer or your algorithm, the zero index becomes empty. So that's the biggest problem. So to fix this problem, you have to shift every single index towards straight to memory address to fill that gap. So if your queue has 10,000 indexes or nodes and that serves to one person, so this is gonna be a biggest performance bottleneck, and your algorithm gonna be so worse and inefficient to handle that operation at once. So today we're gonna bypass that problem by using ListQueue approach. So I want to show you a visual thing first so you can get some idea about this, because they are visual and they have animation, so you get the definite idea of what they look behind the scenes about this. So this is just a linked list approach, and so I have created an animation based on scenario, and you will see these real things that are happening behind the scenes. Alright, so this is the animation thing I have created. So let's look at carefully about this, okay? And we have two methods, Enqueue and Dequeue. Simply, Enqueue means adding. So when you add a node or some kind of element right here, so the data itself lives inside the node, okay? So it's basically just connecting to another node like a chain. So when we enqueue this method again, so it just basically add a new node that becomes the tail of queue, and we add another node, right, becomes, and the second node is 20 and the third node is 30, that becomes the tail, and again we do it, and the 14 and again 15 and 16. So we have 16 nodes right here. So the head one is 10, the tail is 16. So basically this is being just a core principle of a queue. When you're looking at this queue, the head is 10 and the tail is 60. So when you dequeue this, that means you remove, okay? Just simply means removing the node from the queue. So just think in real life, when you are removing someone in the queue, so would you remove from front or back? It's just basically just a common question, right? Common scenario. You are basically just removing from it front, not from the back, because back from the back is where the new persons or new nodes connecting from, okay? The back is just totally connecting to the chain that represent the connecting part of the queue. And the first one is the head, so if you dequeue this, the first one is gonna be removed. And the second one is 20, and the second node becomes the top element right here. So that means when you remove the first element, first dequeue method, when you run the dequeue method, the first node becomes empty and the second one becomes the top element right here. So this is the core thing about queue list, okay? So this is just a very normal and quite simple thing to look at. So as you can see, there is a dequeue method and enqueue method. So we did the dequeue method and just basically removing another node, and that second node automatically became the top element, and the same as the functions right here, and I will show you that what these functions are doing right here. And this is written in Java, and I have just created a virtual runtime environment to show this to you. And there is a method called Enqueue right here, and the Enqueue means just adding a new node, and at least like this means the value of the bigger one, and there's the same as the another methods and the dequeue methods right here. You can see that. So there's a dequeue method right here, and that dequeue method removes the first item right here. Actually, we cannot define that exactly number right here, the value right here. We don't do that because we know that the values are removing from the first element, the first node, not the middle or the back on the queue, right? So this is basically removing or dequeuing from the front of the queue. So this is a very common thing. So that's just very interesting, right? So this is the whole thing about queue. So you just saw that, and how does a queue work, and how does the chain work, and where is the head and tail, and how they are connected between together. And so let's do it once again, okay? So we'll reset this again, and we enqueue, and it's 10 becomes head and tail because there is only one node right here. And I will dequeue it once. I will enqueue this once again, and there appears 20 that becomes the tail of queue, and again 13, 15, 14, 15, and 16 right here. So we have just basically created a new queue right here. So when we are dequeuing this again, and the first node disappears, and the second node becomes the top element, and the dequeue, and the second node, third element becomes the top element. And the same as for it, and the same as before. Alright, that's it. That's the queue. Alright, we have come to the logical part of this now. So I have just basically used the Java for this, and I have just used the Java default linked list right here to import the all functionalities right here. And we have created the class named ListQueue right here. Yeah, you can see that. And we have created an instance variable named linked list right here, and that the value of the data types is integer, and there's a call as list. Okay, so all right, there is a constructor right here. So second, there is the enqueue method right here. So we have created a public void enqueue, and the ensure as item because we need to keep this precise, and we have add the at last item as bigger one. Okay, so the second one is there is dequeue method right here. The dequeue method has a conditional form whether catch up the queue is empty or not. If it's empty, so it just pass a message that says queue is empty right here. So we need it because we don't know if the queue is empty or not. So that's basically a right and professional thing when you're implementing a queue from a programming language like this. So it's just necessary, I think. Yeah, it's necessary. So this basically just means throw a new runtime exception that's default by the Java, and the same message is queue is empty. And so that return list remove first, and that means you are dequeuing the first element as you saw before in the that animation. So you got it, and you already know how to do it, and you know what is happening behind the scenes. We have to demystify the things that we used to think about it. And alright, so there is the main method right here. So finally we have created a main method instantiate the ListQueue for testing. Okay, so there is the ListQueue for testing. We have instantiated that thing, and we have called the enqueue method right here, and the item as 10 and the dequeue as item 20. So we are dequeuing some element right before that right here, and the output should be 10 because this is literally print and just literally removing the first node, and the second node becomes the first element, like you know that you saw that in animation, right? So let's just run this. Okay, yes, there it is. The output is 10. The dequeue is 10 because we are basically just move the first element to the second node that becomes the top element right before the first element is disappeared. So it removed, the first person gets removed and the second one get the second result. So this is just a core principle of the whole queue system. So this is just about the code implementation. You saw it and how to do it. So you can see the code. The whole code is just we created a constructor and we created an enqueue method right here. So and we created a dequeue method right here with a conditional operation right here, because we need to catch if the queue is empty or not. So if empty, we are displaying a queue is empty message right here by default. Runtime exception by Java is also provided by default Java system, and we return the list remove method right here. And there is a main method. We have instantiate the ListQueue first testing right here, and we have at the item 10 and item 20, and we are going to dequeue from the first element right here, and we got the output as 10. So this is the thing. This is the whole thing about a queue. You know that how to implement a highly efficient and elegant code in a fundamental data structure. That's right. So let's look at this is the code, and this is the Java implementation. So this is just basically very intuitive and simply understandable thing, right? So you saw the animation and you saw the code, and you might have get the exact idea about this right now. So this is I think this is very awesome thing, right? All right. Now, before we wrap up, I want to point out some crucial detail about the visualizer you saw before, okay? So you saw that when we dequeuing, the boxes are slightly moving to the forward, right? But in real context, in real scenario, in a real computer memory, that doesn't happen. That really doesn't happen, because your context and in your computer, that memory addresses are in some locations that they were created in. And that nodes are staying where they created in. That never changes, okay? They just jump to the another memory address without just sliding or disappearing like the visualizer you saw that. So it's not the real thing. So just remember that, just keep in mind that. So this is exactly why we bypass the issue that using a high performance and efficient ListQueue approach right here. And so there was actually a huge performance bottleneck as we talked in earlier. So we achieve through constant big O1, and because data stays put and only the lightweight pointers are moved. So that's the basically understandable thing when you are implementing a queue list using this approach. So this is a highly optimized and elegant nice solution for this matter and the huge performance bottleneck that we talked earlier. So this everything wraps up the ListQueue. So in the next video we will talk about aerial trees, and that's gonna be some kind of visual video because they have highly graphical things, and you know that video would be so interesting. So I'm inviting you to hop up with that until the next video. So we will look at how aerial trees handle the unbalanced data through the rotations. So if you got any question about these things, just be okay to show the comment sections below. And thanks for watching. See you in the next video.